Okay, good morning, good afternoon, and good evening. It's a continuation video on the assignment I think we've been solving with you, Mr. Mwanga. So, I think last time I solved question 1 and question 2. So this video will continue starting from question 3, and I'm sure maybe I can finish up in this video, or I don't know how far we'll go, but I think I can finish up. So we'll continue from question 3. Last time we talked about question 1, which was talking about certain sum equations, especially more on the aspect of exponential functions. I think I highlighted what an exponential function is and the type of equations which we can tend to involve, and some of the properties which we can use when solving exponential equations. And I think with exponential equations, like the way we talked about in question 1, it's just about properties, the same grade 1 properties in any other indices, to say when you're multiplying two indices with the same base, what do you do to the powers? When you're dividing with the same base, what do you do with the powers? So this is the concept we are using when solving for question 1. I think I explained and highlighted in the previous video. And then question 2 was talking about the demand function and the supply function. So what is the demand function and what is the supply function? We said the demand function last time is that this is a function which explains a negative relationship between the quantity demand and their prices. So the function which symbolizes or which represents how much price the buyers or maybe the customers are willing to pay is represented by the demand function. So we always put it in an example to say that when you're trying to, maybe you're going to the market to go buy maybe certain phones, there is a price which you start with from home to say, if the price of your phone is 500 kwacha, I'll be able to get. Or maybe you tell yourself to say, if the phone will not be more than 500 kwacha, I'll be able to get it. So there is a certain price a buyer tend to go with in the market, where this person is willing, or the amount of money you are willing to spend in that market. So a certain equation which connects the price and the quantity of demand is the demand function. So that equation which connects the quantities and the price is the demand function, and this demand function, we are saying it should be negatively related between the quantities and the prices. But for the supply, in the other hand, it is what? It is positively related. It's more like the suppliers, they are telling you to say, we can't supply you these items if you don't have this amount of money. So we can only supply you if you have 50 kwacha or more. It means it is a certain price which the suppliers are willing to give you the items at. 50 kwacha or more, we will give you. Anything less than 50 kwacha, we can't give you. That's the price they've set to say, we'll give you something at that particular price. The demand function, it is you are willing to say, I can't buy anything more than 150. Anything 150 or less, I will buy. So supply function, what is happening in the supply function? The more the things you want to be supplied for, the more the price the more the price you're going to have. So it means if it is costing 2 kwacha to manufacture a pen, maybe manufacturing 2 pens, it's supposed to cost you maybe how much? 4 kwacha 1 pen, then two pens obviously to costing you 8 kwacha. So the more the quantities, the more the price. But here on the demand function, the higher the price, the less the demand. So if you increase the price on a certain commodity, you are going to receive less customers. That's what the demand function is telling us. So it's a negative relationship which exists between the price and the demand. I think we explained that. Then we have the equilibrium price and quantities, where this only exists when the demand is equal to the supply. I think we explained that in our previous lesson. So today I want to focus on question number 3. Question number 3 here is now bringing the concept of mathematics of finance. So before I touch solving question 3, I want you to look at certain notes. I think I sent these notes to you. You can just go through them and understand some certain concepts we'll be looking at under the mathematics of finance. So this is the first chapter of mathematics of finance, where in this chapter we'll be more looking at interest in this case. So we'll be looking at interest. So under this chapter we'll be looking at more of interest. So there are two types of interest which you have to understand, even in the school of business or maybe as a business person. There is an interest which are going to be simple interest, and there is an interest according to be compound interest. So what do we mean when you talk about these things? I'm sure we understand their concept, whereby maybe you try to, maybe a simple example I can give, you are trying to get a loan, obviously somewhere, maybe from a bank. Obviously the logic which is existing there is, maybe if you get a loan of a 2000 kwacha, you are expected not to return the actual 2000 kwacha, but you are supposed to you're expected to return it with a certain interest. So what is interest? Interest is more like a certain amount which is added on top of your money you collected. So in this case, the money you collected, you are calling it to be the principal. So we have what is known as the principal here. So now the question is, what is the difference between simple interest and compound interest? So when you talk about something which is a simple interest, we are defining it as a fixed percentage. So this is something which is fixed. It's a fixed percentage of the principal. What is the principal? The amount of money you are borrowing, or the amount of money, in short, it's the amount at the present, the amount of money which you are getting at the present. It is abbreviated as P0 to symbolize the original price, or the original amount which you are grabbing at that instance. Obviously after a certain period of time, you are expecting this money to grow. It's just, we can try to relate this in terms of investment, or you can try to relate it in terms of borrowing. So if you are investing something, let's say you are trying to invest this amount somewhere so that you can yield certain profit, maybe in certain investment companies, or maybe in the same banks. What you are going to do, maybe you have a 500 kwacha. A 500 kwacha, you put it in a bank. You're expecting that 500 kwacha to accumulate certain interest. So at the start, right now, originally I have a 500 kwacha. So it is my P0 which I'm going to be the principal. 0 is just an indication that this is the initial amount I have at the start. In short, we're talking about the present value. Others will be looking at some abbreviation like PV, PF. So PV is the present value, which can also be called the principal in this case. So we're saying a simple interest is a fixed percentage of the principal that is paid to an investor. Who is an investor? Me, who is investing money. I have a 500 kwacha, that is my principal. I invest it in a certain company, and then it will accumulate certain interest. What is this interest? This is a fixed percentage which is going to be paid to an investor each year, irrespective of the number of years. I don't know how many years I'm going to put that money in the bank, but there's a fixed percentage which is going to be added, or maybe a fixed percentage of the principal which is going to be added every year to my principal. So regardless of the number of years the principal has been left on deposit, it doesn't matter. Maybe I can put my money for 5 years, as long as my interest should be accumulating every year. It is a certain fixed percentage. So this fixed percentage is calculated on the principal. So now question comes in, say how do I find this interest? This is the formula for finding our interest. So this simple interest is calculated by PO, which is your principal, and multiplied by I is your interest rate, and multiplied by the time is the number of years you have invested this principal at. So 500 kwacha is what is invested in the company or in the bank. At what percentage are they calculating my interest at? That's my I. So this is the percentage of the principal multiplied by the number of time taken, maybe number of years. So if I invest a 500 kwacha, which is calculated at the interest of 20%, so 500 multiplied by 20%, remember this is in percentage, so every time when you look at the I, we'll be taking this I in terms of in its percentages. So if it's 20%, we'll replace a 20 over 100 to indicate that is a percentage. So 500 multiplied by 20 over 100 multiplied by the number of years, maybe it's 5 years. That's how we calculate the interest, calculated on the 500 kwacha. So on that 5 years which I've invested my money, I'm going to have the future value. In this case, the future value is called the PT. So future value, if the number of years is 5 years, we're talking about P5. If the number of years invested is 6 years, we're talking about P6. So the future value in this case is what I had at first, which is the principal, plus the interest. So PO plus the interest, and think interest is calculated in this manner. So we are adding this interest to the PO. So the PO plus the interest, this is, remember, this is your I, which is your interest. So PO plus the interest, PO plus the interest, we have the future value. So the PO which I invested here was 500 kwacha, plus the interest which I'm going to accumulate by those 5 years. Together I have the future value, which is this formula. So this is just factorized as, if I see the first term and second term, there's something common here, which is a PO. PO is factorized outside. I'll remain with a 1 here, and here I'll remain with IT. That is why we have the final solution to be this as our formula for the future value, or the amount I'm going to have after a certain period of time when interest is calculated in terms of a simple interest. That's what we are talking about. So PT will be equals to PO 1 plus IT in brackets. This is a situation where I'm finding for PT when a PO is equals to PT with future value, which will be equals to the principal multiplied by the 1 plus IT. It's a general formula for finding the future value when interest is a simple interest calculated. So what are we saying under simple interest? This is a fixed percentage, but we have something else which is called a compound interest. Now what is the difference between simple interest and compound interest? Because your assignment has questions concerning compound interest and not simple interest. So what's the difference between these two? Simple interest is a fixed percentage on the principal, but what about compound interest? When you look at compound interest here, when you look at compound interest in this case, okay, here it is, compound interest. When you look at compound interest here compound interest is, this one pays interest on the principal plus any interest accumulated previous years. So the difference between simple interest and compound interest, simple interest, it just calculates the interest is calculated on just the principal. What you invested on the start is what you are going to calculate for. You say, okay, if you invested 500 kwacha on the start on day 1, so our interest is just a fixed percentage calculated on 500 kwacha, is what we are going to add every year for you. So every year we'll add that amount, which is the interest which was calculated on 500 kwacha. Every year is what is going to be added. But for the compound interest here, compound interest in this case, it is interest calculated on the principal, the amount we had at the first, as well as plus any interest accumulated in the previous years. So we calculate the interest on the principal. It means what we calculate on the interest on the principal, I will add it in the first year. In the second year, the interest it won't be the same interest as the previous year. So we will now calculate, this time around, the interest which is going to added on top of your money. It is based on what you have on the previous year. So let's say if I have a 500 kwacha this year, I invest it. So next year, my money, maybe let's say we calculate interest and I have maybe 520. So what was added was a 20 kwacha. So the other year, it means I'll have a 520 kwacha, not 500. This time around, from them to add interest on the 520, they will have to calculate interest on 520 instead of the 500 kwacha. So that's what we have to understand on compound interest. So it is interest calculated both on the principal and the interest you have received previous years. Principal and the interest received from previous years. That's how compound interest is calculated. So now what's the formula for? Here we have the general formula for the future value. How much am I going to have if interest is a compound interest? So future value is equals to PO, the amount I invested, open bracket 1 plus I. I is the interest rate. But this time around, remember, simple interest, for me to have the future value, muka to umma brackets, they could have been I could have 1 plus IT. But since this is a compound interest, the future value will be equal to PO 1 plus I in brackets, then the T is a power, indicating that for me to have this future value, the interest which is accumulated is a compound interest and not a simple interest. I believe we have gotten that one. So now we have to understand again now that if this is a compound interest which we have, this is the general formula. But this interest can be compounded in multiple times, several times. So in a year, how many times are you compounding that interest? So if interest is compounded annually, it means the interest, you are just adding interest every year. If interest is compounded twice a year, we call that as semi-annual. So there are different types of interest which can be compounded. I think if you look at this example, what am I having here? I can calculate interest when I can calculate a future value when interest is compounded annually, semi-annually, quarterly, monthly, or daily. What does annually mean? So when you are calculating interest, you are compounding several times, the formula will change. Now look at this. PT is equal to PO open bracket 1 plus I power T. This is the general formula when interest is compounded every year. Every year it means annually. So it means if I tell you to say, can you calculate the future value when interest is compounded annually? Don't even stress, just use the same formula in without stressing. So what is happening here? You just find what is your PO. PO is your principal. In this case, it's a 60,000. Invested at what interest rate? It's a 6%. How many years? 10 years. So if it is compounded annually, it means PO will be 60,000. I 6% will be written as 6 over 100 as a percentage. T is time in years over 10. And remember, in this case concept, every time everything when we are trying to calculate these things, time should always be in years. Sometimes you can be given time in months, you have to convert it to years. So time taken here is 10 years. So in the case of a direct papa T is equal to 10 years. So this formula, it is when interest is compounded annually. So you just tabulate, compute with your calculator there. In the brackets 1 over that, this is just 0.06 plus 1 becomes 1.06 power 10. the answer multiplied by 60,000. Now the question comes in to say, what happens when I want to calculate the future value this time around? This time around, I am now looking for interest when I'm looking for the future value when interest is compounded semi-annually. Semi-annually means we are compounding interest twice a year. We are compounding interest twice in a year. So compounding interest twice in a year, what does it mean? So it means every year our interest will be compounded twice. So it means even our formula is affected. So our formula in this case will be affected. So how am I going to affect my formula? I'm going to have, remember your general formula is PT equals to PO 1 plus I power T. So depending on the number of conversions, that's how your formula is going to be affected. What do we mean? We're talking about I to be divided by the number of conversions, T to be multiplied by the number of conversions. So in this case, I'm talking about semi-annually. Semi means we are compounding interest twice. So that time which I have, I multiply by the number of conversions. So list your data. Number of conversions here is 2. That is why I've written M is equals to 2. Time taken is 10 years. The I is 6%, which is the same as 6 over 100. Now the question comes in to say, how do I replace all these things in my formula? Principal is still 60,000. 1 plus I is 6%. If you wish to, you can even calculate this in advance. 6%, 6 over 100 is just basically what? 0 point, what? Is it 0.6? Yeah. So 0.06, that's the I. So you replace it there. So if you replace it there, we are dividing this interest by the number of conversions. How many conversions do I have here? It is 2 conversions. So it will be I over 2, and I is 0.06 divided by 2. And remember, your time here was also multiplied by the number of conversions. I have 10 years multiplied by the number of conversions, which is 2. So we have 20 as the power now. 0.06 divided by a 2, I'm going to have 0.03 plus a 1. 1 plus 0.03, the answer, power 20, the answer multiplied by 60,000, and you should have that. So in this case, we have solved the future value PT when my interest, which is added on the principal, is compounded semi-annually. So under compound interest, the key is knowing how many times are you compounding your interest with. Are you compounded annually? If it is annually, the formula does not change. It still remains the way it is. But if it is any other compounded conversions, then the formula changes. The only effect is on the number of conversions. Semi-annually means it's compounding it twice. Quarterly means you're compounding it 4 times. Monthly means you're compounding it 12 times, or 12 months in a year. Daily, you're compounding it 365 times in a year. So this formula is going to be affected like I divided by the number of conversions and T multiplied by the number of conversions. I divided by M, M multiplied by T. That's how your formula is going to be affected. But if it is annually, maintain the way it is. Compounded several times indicates the number of conversions you are dealing with. Quarterly there, M should be equals to 4. Replace 4 times 10, 0.06 divided by 4. You do your calculations. If it is monthly, we're talking about the number of conversions to be equal to 12. Replace 12 multiplied by 10, I divided by 12. Do your calculations there. When it is compounded daily, m this time around is now going to be equal to 365 times. So it will be 365 multiplied by 10 as the power, and 0.06 divided by 10. That's what we are talking about there. So this is our summary here. We are saying that when interest is compounded several times, in short, when we're talking about simple interest is calculated in this manner. Simple interest is calculated in this manner. PO multiplied by I multiplied by time. And then the future value for simple interest is PO 1 plus IT when interest is added. But when compound interest is added, PT becomes PO equals to 1 plus I power T. When compounded several times, it changes to M times T, I over M. Now this time around we have when compounded continuously. What do we mean? Continuous compounded means you can't count. It's difficult to count how many conversions you are having in that year. Maybe this interest is compounded every minute or every second or every hour. So it's difficult. So we are trying to treat it as a compounded continuously interest. So the formula becomes PO. What is PO? Your principal. E is the Euler number. This is just taken as 2.718 approximately. So 2.718 approximate, what we mean here is even on the calculator you'll be able to find it. 2.718, just like pi. Pi is 3.142, but this one is also an irrational number which is represented by 2.718. This E is not just a data or a variable, it is a number represented by 2.718. RT is a power. RT is just memorizing time multiplied by the interest rate. That's what we have there. So this is a summary of the compound interest. Now let's go back to your assignment. Just running through. Here the question says what? The question says a financial institution pays 15% interest compounded continuously. You are being told it's compounded continuously. Remember what you are just from saying. Compounded continuously means the future value PT should be equal to the PO multiplied by A multiplied by RT. So compounded continuously, and then the question is how long? The question is how long? How long means what? Time taken. How long will it take for 2000 to grow to 9,000 kwacha? So we have two things here. This 2,000 should grow to 9,000 kwacha, and then interest should be continuously compounded. So how long should I put this 2,000 kwacha in investment for it to later on turn into a 9,000 kwacha? So this becomes my what? My PO. This becomes my what? My PT. Remember, I can still symbolize this as PV. Others will say PV, it means the future value, or FV, it means the future value. So PT is future value, PO is the present value. This is my interest rate I, and we have to find 15 divided by 100. So for the key word here is compounded continuously. What is the formula for compounded continuously? Recall that formula and replace everything you have. So you have PT, which is 9,000, you replace. PO is 2,000, you replace there. E is just an Euler number, it's on your calculator, nothing like stressing. R is 15 over 100, which is just as good as 0.15. Then when you replace there, 9,000 is equals to 2,000 e power 0.15t. We are looking for the time taken here. So this becomes an equation. So we delete 2,000. Remember, it is 9 pin, it is 9000 equals to 2000 e power that. So for me to find this t is in the power. That's why we divide both sides by 2000. Both sides we divide by 2000. So divide by 2000, divide by 2000 after from the replacing. So this and this go will remain. This side 9000 divided by 2000 is 4.5. This side after we delete we just remain with e power 0.150. Now this is a power. This takes us back to exponential equations. So if something is a power, the only way it can come down is by applying logs on both sides. So now the log which I'm going to apply is a natural log, since we are dealing with the base of e. So if you are dealing with the base of e, you have to apply a natural log which is ln on both sides. So that if I apply a natural log on both sides, we are going to punch on our calculator a natural log of, or maybe, yeah, natural log on both sides means natural log with this side, even natural log with that side. So that when you be looking at properties of logs, it means if I have a log of this base power that, this power can drop down, becomes 0.150. Since according to properties of log, we have to understand that the properties of log we have here is that natural log of e, every time just know that natural log of e should be equal to a 1. So it means that if I apply natural log on both sides, when this one drops down, I'm going to have 0.150 multiplied by 1. I still have natural log of 4.5. So what do? I need to solve for t. That's why I will divide again both sides by 0.15. So dividing both sides by 0.15, I remain with t to be equal to the natural log of 4.5 over 0.15. Because this will cancel, I will remain with t to be equal to natural log of 4.5 over 0.15. You calculate on your calculator, punch natural log of 4.5, the answer divided by 0.15. You need to have something of this, which means the time taken, which is t, for you to grow 2000 to become a 9000, the time taken should be approximately 10 years for that to happen. And you are done with question 3. So question 3 is continuous. It's continuous what? Compound. In short, it's compounded continuous. So the key formula is that. But when you go to question 4 is in two cases there. You are being told that a newly graduated college student has invested 5,500 at this percentage, which is compounded interest per annum for 4 years. Remember, what does per annum mean? Per annum means yearly. So we said that if it is per annum, if it is per year, the formula is not changed. I used the FV here is still okay, even using this formula, which is this one, which is PO 1 plus I power t. Sometimes you can say this t can tend to n. N is just representing the number of conversions, which is the time taken. Sometimes you can have I to be written sometimes as R. So don't get confused. So FV is just representing the future value. Or you can, if you want, you can say what PT and FV is the same thing. P here is the PO, what you're investing. 1 plus R. R is the interest rate. N is the time taken. So since this time we're saying that it is compounded per annum, it means yearly. It means we're just taking the number of years as they are. 5 years we replace there. R is a percentage, 9%. 9 over 100 becomes 0.09. So 0.09 in brackets plus 1, which is 1.09 power 5. The answer multiplied by that, and then we have this future value there. This is our PT or our future value. So calculate the value of the investment of the at the end of 5 years. This is the value of the investment at the end of 5 years, because this is compounded per annum. Per annum, it means there's nothing like divided by the number of conversions. It is just divided by 1 yearly. What about B? B is saying compute the present value. This time around, we want to find the present value of receiving a 12,000 kwacha for 4 years. So assume that after 4 years, you are going to have a 12,000 kwacha at the percentage of 9%. What did you invest in the first year? So it's just as good as the same formula here. We are finding future value. We had the present value, but it's a vice versa now. You have the future value, you are now solving for the present value. So this is what is happening here. So when I want to find the present value here, given the future value, it's just as good as making PV the subject. So I'll divide both sides by 1 plus r power n by this guy, so that when it cancels out, it goes this side to be future value divided by 1 plus r power n. So divide both sides by this guy, so it cancels out, it goes this side, so that you can have future value over 1 plus r power n. Remember, r is the interest rate. Future value is the amount you are going to receive after 4 years. Time taken, it is 4 years. Replace everything there. Future value is that, interest rate 0.05 plus 1 power 4. So what you are going to calculate in the denominator here, the answer you divide into 12,000, and the present value you are going to have, it is this, which is 8,503.4 kwacha. As simple as that. So if you look at what is happening here throughout, it's just as good as you understanding how many times are you compounding that interest on. That's all. That's the only thing you're supposed to understand. Let's look at your question 5. What is question 5 saying? State the difference between an annuity and a perpetuity. I think that's just a statement you have to understand. So an annuity, I'm sure you can just be pausing. If you want to, this is a video, you can be pausing and take a deep breath. You would note down the point that you have understood before you continue. So what is an annuity? An annuity is just an equal payment made at regular intervals for a fixed period of time. For a fixed period of time. And then when you look at, is this supposed to be wow? When you look at a perpetuity, perpetuity is just equal payments made at regular intervals forever. There is no ending time here when it comes to perpetuity. Annuity, it has a fixed period. It means you have to make sure you complete maybe your payments in a certain period of time. But perpetuity, there is no end. It can be forever, just making those payments, equal installments, equal payments. It has no ending. That's the difference between an annuity and a perpetuity. So yeah, maybe you try to think of it in the situation whereby you got a loan of a 20,000 kwacha, and then you agree to say, I'll return back this 20,000 in equal installments paid at certain intervals. By certain intervals, you agree to say these intervals, are they going to be yearly, are they going to be monthly, are they going to be semi-annually, or are they going to be quarterly, etc. So for an annuity, it has a fixed period to say, oh, I'll pay this amount in this period of time. Now interest you now repeat up. But perpetuity does not end in yen. It takes forever in most cases. I think we've defined what a compound interest there is. A compound interest, this is interest calculated on the initial, which also includes accumulated interest from the previous period. I think we've defined that. Now there is another concept, these two. There is another concept which you have to understand on these two. That is the NPV, which are going to be the net present value, and the internal rate of return. What is the net present value and what is the internal rate of return? So the net present value, I'm sure we understand present values, amounts at the present. Yeah. So this is the financial metric that calculates the difference between the present values of the cash flows, inflows, and the present values of the cash outflows over a period of time. So you calculate the certain present values of the cash inflows, or maybe the amount you'll be receiving from your business, and then you subtract the amount which you invested in your business. So that difference is simply giving you the NPV. So mostly this process is used to check whether your company is yielding certain profit, or maybe the project you've invested in is simply worth it to go for or not. I think, let me just go to my notes here. If you look at these notes, I even sent you these notes. So what is this NPV? We are saying that it's a difference between the present value of cash inflows. What do we mean by cash inflows? Money we expect to receive from the investment. Those are the cash inflows. So the difference between the present value for the cash inflows, what are you expecting to receive from an investment? That's what we're talking about, the present value for the cash inflows and the present value for the cash outflows, money spent on the investment. So that difference is what is going to give you the NPV, which are according to the net present values. So it tells us how much value an investment will add in today's terms. So how much investment will it add in your business? So the important rule we are going to be using in this process is that when NPV is greater than 0, this means that we can accept the project. It means it's profitable enough. By greater than 0, it means the difference is something which is positive. But if the NPV is negative, it means that project you've invested in, you just have to reject it. You don't have to continue with it. You reject. So that's the difference. That's the rejection rule we'll be using when it comes to the NPV. So from the formula here, saying that NPV should be equal to the present values of the cash inflows minus the present values of the cash outflows. Remember, inflows, the money you're expected to receive. Outflows, the money which you invested or which you spent out. And the decision rule is when NPV is greater than 0, you can go ahead and invest in the project. If NPV is less than 0, you don't invest in the project. So what are we finding? We are finding all the present values of the cash inflows. At the same time, again, we are finding all the present values of the cash outflows. But you have to remember this formula. It is still coming from the compound interest. Future value, which was saying that formula to say future value equals to what? Let me go back to your note. We said that what? This was the formula. Future value is equals to present value open bracket 1 plus r power n. This is the formula you are looking at. But this time around, we are looking for present values. That is why we have a certain new formula where we make PV the subject. So this is the formula for the PV. So it means that when we are looking for the NPV, our main focus is on the PV formula, the present value formula for each cash inflows and for each cash outflow. So the present value formula. So there must be a certain future value at that particular time. Now discount it and take it to the present. That's what we mean. So discount it and take it to the present. So this is the formula we are going to be using. So you can either use this formula or you can take this per number, but the power will be negative nt. It's this one and this one is the same thing. It's just that this one is written as a positive index and this one is written as a negative index. It's the same formula. If you want to take this on top, it means that the power will be negative nt. It's the same thing. So what are the steps to consider when you're trying to solve for NPV? Identify the initial cost. What is this initial cost? This is the cash outflow, and it is usually at t equal to 0. It's at the start in most cases. So you identify the cash outflows and then identify the expected cash inflows, expected amount you are trying to receive for each year. And then after that, calculate the present value for each cash inflow. This formula, for each cash inflow you're going to have, calculate the present values. So after calculating the present value, we need to sum all the present values. We sum them up, add all the present values, and then subtract the initial cash cost, which is the cash outflow. Once that is done, it means you have found your NPV. So I'm sure you can go through this document I sent you just to cement through and understand about more on NPVs and the like. So now we are coming back to the question, which is question 5b, where it's saying, this is your STEM assignment, which is saying that the KMG suppliers run two businesses. There's business A and business B. So stationary materials, which is for A, and second entity B supplies electrical accessories. So the cash flows for two projects, there's project A and project B. The cash flows for these are shown in the table below. So the cash flows in year 1 were that, year 2 were that, year 3 were that. These were the cash flows for each business in year 1, year 2, and year 3. So what are we expected to do? We are being told to suppose the initial cost, remember the initial cost of each project is 1,800 kwacha, and the cost of the capital is 8%. That's the interest rate of the capital was 8%. What are we being told? Calculate the NPV of A, at the same time calculate the NPV of B. After you do so, determine which project is better. As simple as that. So what do we do? Remember the steps? We said how do we calculate the NPV? The steps are how? Identify the initial cost, number 1. So what is the initial cost in this case? Our initial cost is 1,800. So we've identified our initial cost. Discount rate is 8%. If you want, you can now convert it to a decimal. 8 over 100 becomes what? 0.08. Now after doing so, we now start finding the present values for each cash inflow. In year 1, I have a 700 kwacha as a cash inflow. In year 2, 550. In year 3, 450. This is for project A. So we have to discount all these projects, all these amounts to the present. This is our formula, remember. So in year 1, discounting it to the present value should be equal to future value over 1 plus r power n. N is the time taken. Year 1, it means n is 1. Year 2 means n is 2. Year 3 means n is 3. Future value in year 1 is 700. We are looking for the present value. Discount rate is 0.08. 1 plus 0.08 plus 1. And then present values for 2, 500 is the future value. As usual, the discount rate is still 0.08 plus 1 power that. The same you do to the 450 kwacha. So these are the 3 years, and these are the cash inflows for the 3 years, and these are their present values which we have calculated. These. What is the next thing to do? The next thing to do is summing all the present values. So we sum them up now. So PV1 plus PV2 plus PV3, we sum it up. We are going to have the total present values which we are going to have there. So the total present values which we are going to have, recall the formula. The NPV should be equal to the sum of all the present value for the cash inflows minus the initial cost. So the initial cost is just the as usual as the present value for the cash outflow. So summation minus the initial cost. That is why we have this minus that. This is negative 323.02. Keep it. Before you conclude, keep it. Let's go to project B. Project B has these cash flows every year from year 1 to year 3. So year 1, year 2 and year 3. So the same thing as we did in the project A. We have to find present value for 450 in year 1. We replace in the formula. Present value for year 2, we replace in the formula. Present value for year 3. Remember the formula, and then sum all the present values. So when you sum all the present value, we have that, and then when we subtract, we are going to have that. We subtract the what? The initial cost. The initial cost has already been given for both to say it is 1,800 kwacha. So compare now. This is the NPV for project B, and we are the NPV for project A. So comparing the two numbers, what will be the decision? Remember I said that if something is greater than 0, that's when we can accept. If it is less than 0, we reject. But both of them are less than 0, so it means we just try to check which one is better than the other. So the decision here, if you look at project B, it's better project to invest in because it has a higher NPV than project A. Negative 15 is bigger than negative 323. So negative 15 is bigger than negative 323. So project B will be a most suitable project to invest in compared to project A. As simple as that. So that's the concept of how you have to deal with the NPVs. So the net present values and their decision rules, this is how we deal with them. Yeah. The last question on your assignment, question 6. I think question 6 is not that complicated. It's just an issue of understanding. Number 1, you are being told there is a demand function. What did I say about the demand function? Demand function gives you the price of how much the buyers are willing to buy the items at. So demand function for a good is given by Q equals to 65 minus 5p. The fixed costs are 30 kwacha and each unit produced cost an addition of a 2 kwacha. So write down the equation for the total revenue and the total cost in terms of Q. So now, what is the total revenue? Total revenue is the amount you receive. So if you take yourself as the business person, total revenue is simply the amount you're going to receive from your business. So this total revenue is coming from this concept to say it is price times quantity. So if you're selling pens, total revenue is coming from your pens which you are going to sell. So if one pen is costing 20 kwacha, so if you sell one pen, your revenue will to 20 kwacha. If you sell 2 pens, your revenue will to 40 kwacha. So total revenue is the amount you are receiving from your business, from that good. So depends with the price you are going to set for that quantity. That's how your total revenue is going to come out. So now, if this is my total revenue formula, I need to know how much am I selling per good, per item. So the how much you are going to sell is going to come from the demand function. So the demand function is given by Q to be equals to 65 minus 5p. That's your demand function. So what do you have to do is you have to make P the subject so that you can find the expression for price. First express P in terms of Q so that you can have the expression for what? For price. So that you know, say, okay, how much are the buyers willing to buy my good at? So that expression is going to give, that price is going to be given in the form of an expression from the demand function. So that is why we, from the demand function, we are making P the subject. To come up with an expression for price, we are going to put for each goods we have. So if we make P the subject here, what is going to happen? Negative 5P can go the other side, becomes positive 5P. 65Q go this side, becomes negative 5Q. I mean, we delete the 5 by dividing both sides, all the sides by 5. So we divide by 5, divide by 5, divide by 5. So if I divide by 5, the 5 and 5 will go, remain with P. 65 divided by 5, I remain with 13. There is a 1 here. 1 divided by 5, the answer is 0.2Q. So the price expression, it is this. And since the total revenue, we've said it is price times quantity. So this expression should be replaced upper the P upper, then we multiply by quantity. So the expression for total revenue becomes P times Q, then P is equals to this, we replace upper the P. So it is 13 minus 0.2Q multiplied by what? Q outside. What do I do? Just expand. So Q times everything. Q times 13 becomes 13Q. Q times 0.02Q, it becomes negative 0.2Q squared. So this is my expression for the total revenue. We continue and find the total cost. Total cost is given by the formula fixed costs plus variable costs. Fixed cost from the question, it is 30 kwacha, which has been given. It is already stated from the question. Fixed cost of 30 kwacha plus the variable cost. Variable cost depends on the quantities being collected. So the question says each unit produced cost an addition of 2 kwacha. Each unit to produce it is costing you 2 kwacha per unit. So it means every unit you produce is a 2 kwacha. So the variable cost in this case will be 2 times Q. 2 kwacha times every unit you produced. So that is why the total cost becomes the cost which is fixed plus the variable cost. So together we have a total cost of 30 plus 2Q, and this becomes our total costs expression. So we have the total revenue expression and we have the total cost expression. As simple as that. And B says find the break-even point. What is the break-even point? So the break-even point, this is the value or the values of Q that makes total revenue to be equal to the total cost. So in short, solve for Q when TR is equal to TC. From the expression which you found, TR is this and TC is this. Equate the two and solve for Q. So TR to be equal to TC, this is my TR expression to be equal to my TC expression. Then we'll solve the value for Q where these two are equal. So where the two are going to be equal is as good as like terms together. Everything can go on one side, we remain with a 0 on the right side. So there's 13 minus 0.2Q. When this one crosses, it becomes negative 2Q. When this one crosses, it becomes negative 30. We remain with a 0 on the right hand side. Like terms together, 13Q minus 2Q, we remain with 11Q minus 0.2Q squared minus 30. This becomes a certain expression we're going to have. And what expression is this? What equation is this? This is a quadratic equation. We are looking for what? We are looking for the value of Q. And this is a quadratic equation. Isn't it? So, you can use any method you feel like using. Sometimes you can even use the formula method if you feel like it. Because you are using calculators, you guys. The formula method, find the value of Q using that formula method. Right, chibasa. So Q equals to negative B, positive or negative, the square root of Shanshan. You use it. If you're able to use the factorization method, use the factorization method. If you're able to use the completing the square, use the completing the square. So this is the formula here. I used my formula method here. That's what you can use as well if you wish to. So I can take this equation the way it is here and use the formula method to replace in the formula method, but Sometimes it's just as good as to break it down into simple versions. So how do I break it down? Sometimes mathematics are about having big eyes, because this 0.2, I know that this is just the same as 1 over 5. Remember, this 0.2 is the same as 1 over 5. So for me to make it as a whole number instead of a decimal number, I know to say the only way I can make it as a whole number is just to multiply it by 5. And again I multiply by negative 30 to make this q squared positive. That's a technique. If you wish to, with this process, you can skip it and just go direct to the formula method, but you will use this equation here when you're using the formula method, where this will be your A, this will be your B, and this will be your C. But since me, I multiplied by negative 5, I have a new equation which I'm going to find, which is this one, when solving for Q. So it's just up to you. Then I'm sure we know how to use the formula method. Replace everything in the formula there to solve for Q. You have your calculator and you have two values of Q now. So these Q's values are the break-even quantities. So this is Q1 is equals to 2.88, which can just be approximated as 3 units. 52.12 is just approximated as 52 units. So these are the break-even outputs which you are going to find. As simple as that. And then when you go to graphing, number 1, total revenue is a quadratic function. How do you graph a quadratic function? When you're graphing a quadratic function, number 1, find your turning point. Turning point, remember, in grade 1 to end at negative b over what? 2a. I think there is also in a document of how to graph quadratic function. I think I sent you. So just try to follow through how to graph quadratic function. So find your turning point. So from the turning point, then there are some cases whereby if you wish you can just use a table of values. It's still okay, just to plot out. Sometimes they can even give you a graph paper in an exam, and then you are trying to plot the total revenue and the total cost. Just use your nancan. So find your turning point. The coordinates of the turning point will be obtained from negative b over 2a over 4ac minus b squared over that. So this is the x coordinate and this is the y coordinate. And then we have 12.5 and do that nancan. This is the turning point. It means when graphing, this point should be clearly seen. TR intercept, the point where it's going to cut the TR axis. That's where, remember, there is the TR this side and there is the Q this side. That's what we mean. So there is a turning point here which we found, and where it's crossing the y-axis, it is at 0. When Q is 0, TR will be equals to 0. Just replace Q to be 0 and so for TR, and you find that it is passing through at 0, 0 there. Quantity intercept, when you solve for Q when TR is 0, you'll find that Q is equals to 0 and Q is equals to what? 65. The point where this graph is going to cut the x-axis. So these points are just important for me to see where I'm going, how I'm going to graph. So that is why you find that this graph is going to move in that direction. Yeah. The turning point is at that point and the intercept is at that. The same thing you do for the total cost. Total cost is just a straight line. Straight line, just find the intercepts. Intercept number 1 is at 30. When Q is 0, the TC is equals to 30. It means it's this point here. The other point you can find sometimes is any other point. So it means this is a straight line. Just find 2 points. When you point another nancan, then you're going to have that this guy is going to move in that direction. Straight line passing through at 30. In that man. The quantity intercept is negative 15. When TC is 0, it means upper is at negative 15 after 0 going in this direction. So number 1, I want to graph both of them on the same Cartesian plane. So these graphs, the total cost and the total revenue, are intersecting somewhere. So the point where they are meeting from is the point where we are going to be the break-even points. So at this point you found in your question to say this was 2.88 and this value of Q was 52.12. Those are the break-even points. So those are the important things which you have to just show. This is just a sketch, not for accuracy, but just do a sketch to represent your graphs. Yeah. For more information, I think you can go through the documents I sent you. Otherwise, this is your whole assignment. I think you can be able to grab something with the solution document I sent you and with my voice being heard in this video. Otherwise, thank you very much, Mr. Mwanga, and have a blessed, I think, week ahead, and see you in assignment 2. In case of any queries, you can inbox, and I'll be able to highlight where you are not getting the point. So you'll be able to let me know when we can start assignment 2, and we'll guide. Thank you very much.